I said coterminal just means that the angles end in the same place. So it says this weird symbol here is the degree angle of a measure, then all angles measuring that same degree plus 360 times n to any amount where it's an integer is coterminal. Here's what that's saying. If you had an angle that's like 5 degrees, that is coterminal with the angle 365 degrees. Those are coterminal. What they mean is if you went on a circle, let me get here. If I had a circle and I found the angle 5 degrees. So when we start finding angles, what you'll learn is that we start at the x-axis, and let's say that's 5 degrees. Well, this angle right there is just the same as the angle that goes all the way around and hits it like that. It still looks the same. They still end in the same spot, so it's coterminal, even though this one made the full trek around, and the first one was only from the x-axis up. So you see that 5 degrees would be very similar to 365 degrees because one goes all the way around and ends in this spot, and the 5 just goes up. So that's coterminal. In radians, you would add 2 pi times any amount. So if you had 1/4 pi radians, that would be the equivalent of adding 2 pi to this, which 2 pi, right down here, is the same thing as 8 pi over 4, because 8 divided by 4 is 2. So that would mean that 9 pi over 4 is equivalent to 1 pi over 4. They would end in the same place. So that's all this is saying for coterminal. So let's look at example 3. It says identify all angles that are coterminal with 80 degrees. Then find and draw one positive and one negative angle that's coterminal. So to find all, the formula is, if you remember from just past there, it said add 360 in degrees, where n is any integer. And the way to represent integer is, I know you've seen like XER, which means all real numbers, and integer is like a Z with a double-sided there. So that would be like this. So an example would just be if I added 360, here's a practical example. If we added 360, we would get a coterminal angle that is 440, and that would be one answer. So up here is the formula to find them. And then if I wanted to find a negative, all I would do is instead of adding 360, I would just subtract 360. So if I subtract 360, I get negative 280. And that would also be coterminal. And so we look over here at our picture, and it shows us, here's what 80 degrees looks like, this one. And if I added it, I would get 440. So it just goes all the way around. Just the same. If I subtracted 360, I would still end at the same place, but negative would mean go down from the x-axis rather than going up, and I would end up there with negative 280 degrees. So let's try part B. This time we're looking at radians. So it says identify all that are coterminal with negative pi over 4. Well, remember the formula. We add 2 in pi to this. So we start here, and we would add 2 in pi, where again, n is an element of the integers. I'll try to make this double Z a little bit easier to see. So that's our formula. So now if I just practically wanted to find, let's find something that's coterminal. Well, I would first add 2 pi, which 2 pi is the same thing as 8 pi over 4 if I got a common denominator, because 8 divided by 4 is 2. And so if I added these, I would get 7 pi over 4. Now that's one angle that's coterminal. And now to find another, I would take that negative pi over 4, and this time instead of adding 8 pi over 4, I would subtract 8 pi over 4. Well, I already have negative 1 pi, so if I have negative 8 more pi's, then I have negative 9 pi over 4. And that should be my other answer. When we examine the graphs, we see that here, negative pi over 4 just means go down pi over 4 radians, so that's the angle there. 7 pi over 4, you can see, is also coterminal. It ends in the same place. Coterminal just means they end in the same location. And now let's check this one. We have negative pi over 4, or You go all the way around and end up with negative 9 pi over 4. So now you can go ahead and try this one.